8.4 differential equations. This should be one of our shorter videos. We're not doing everything in 8.4. A lot of the word problems we're going to forego, but we are going to still do differential equations. It is easier, so we have two different problems here. It is, in my opinion, easier whenever you see a y prime, change it to dy dx. It's much easier to work with when we have this, okay? So let's focus on the first one, though. What I'm going to do is dy is going to be on one side and dx is going to be on the other, okay? So I'm going to multiply both sides by dx, and I have dy equals x plus 3 dx, okay? From here, I'm going to integrate both sides. Notice it looks goofy, but that left side is just like 1 dy, so the integral of 1 is just going to be y. And then for the other side, you're going to get equals 1/2 x squared plus 3x plus c. Then we can move everything over. And when we do that, we'll get y minus 1/2 x squared minus 3x equals c. Now, your book took this answer here. Sometimes they want everything moved over here. I'm guessing since we got y alone that it's easier just to leave like that. If y is not alone, then I'll move things around if you like. Okay. So we have this one right here. Y prime equals 5x over y. Same story as before. I'm going to multiply both sides by dy. Excuse me, not dy, dx and y. Why? Because that's going to get me y dy over here. Let me use a different color just so it's clearer what I'm working on. I'll get y dy here equals 5x dx. We're going to integrate both sides, and you're going to get y squared over 2, or 1/2, equals 5 over 2x squared plus c. And then I'm going to move, since it's not strictly y, I'm going to move that 5 over 2x squared to the other side. And then finally, for our last step, since the right side's a constant, just a number, what we can do is multiply by 2, and constant is just going to be just a number anyways. So it's going to be y squared minus 5x squared equals c. Will be our final answer. All right, last problem we'll do together, and this is kind of a tricky one a little bit. So I'm going to do the same thing we did before and multiply both sides by dx. No, I don't have a denominator now. It will be parentheses y plus 3 on the other side, dx. Now, I cannot integrate this with respect to x here because of that y. So I'm going to divide both sides by y plus 3. Just like the other problems, we need to move all the y's on one side and the x on the other. Okay, since the plus 3 is attached to it, I'm going to move that over here. So I'm going to be left with 1 over y plus 3 dy equals dx. Now we are going to integrate both sides finally. And integration of the right side is going to be x plus c. The other side is going to be the ln of y plus 3. Now, I would be cool with this answer right here. Your book does want you to isolate y. And to do that, if you put both sides to the power of e, that's going to get us y plus 3 over here. And then on the other side, e to the power of x. Plus c. I guess since it's an individual, it should be c times that, which means I can bring that up front. And subtract 3, get y equals c e to the power of x minus 3. Just to reiterate what I just did with that exponent rule. If I put both this and this to the power of, with the base e to its power, You can multiply these two, and then using our exponent rule, I just brought it up front. And this is your answer, but as I said, I'm cool with this as your answer. That's fine. But your book will want that. All right. Appreciate you watching. We'll see you later.